This question is given for 2 marks in 2019 for EC Gate. The quantum efficiency, symbol eta, and responsivity are at a wavelength lambda in micrometers in a pin photo detector are related by. So first of all, quantum efficiency is defined as the number of carriers collected that can be figured out by the current due to incident photons divided by Q. The light current tells us the amount of charge flowing per unit time. When we divide it with the unit charge value, we get number of charge carriers flowing per unit time divided by the number of photons incident. So if you look at this, the value that we know is the incident power. So if you divide this with the energy of a photon, power is nothing but energy per unit time. So if you divide this with h nu, we would get the number of photons flowing per unit time, or number of photons incident on the pin photo detector per unit time. So we have per unit time in the numerator and denominator, hence they get cancelled. So we have the number of carriers collected to that of the number of photons incident. So if every photon results in a carrier collected at the pin photo detector, it would become efficiency of 100, which means every photon has resulted in carriers collected. So we can write this equal to IL over the incident light power times h nu over Q. We can write this again as IL over Pn times, we know C is equal to nu lambda. Let me put this here, nu lambda. So I'll substitute for nu here, which is h C over Q lambda. And we have seen this standard value when we were doing light interaction with semiconductors. This is equal to 1.24 in terms of electron volts per lambda in terms of micrometers. So this is quantum efficiency. In fact, to be precise, this is called external quantum efficiency. Now coming to responsivity, responsivity is for the incident light power on the photodetector, how much current is actually produced. So that can be found with this ratio, that is IL over Pn. This is in fact in amperes per watt. So this can be written in terms of quantum efficiency, because if you look at the options, that's how it is. So IL by Pn, we also have it in quantum efficiency. So we can write this equal to eta times lambda over 1.24. So responsivity can be written in terms of quantum efficiency and a wavelength, and wavelength is already asked to be in micrometers. This is also in micrometers. So this is the relationship between responsivity and quantum efficiency. So the option is option A, which is correct.